the water is rising. So I know that this is just a distraction, basically. So this is much more powerful than this. Way more powerful, as we expected from the beginning. Because at any point in time, the level is rising. So then I have to think in these terms. The volume of water existing in the tank is what I pump in minus what it goes out. Then I was looking at the volume of water that exists in the tank. So it's a form of a cone. I have to determine the radius. So this is the volume of water. So I need to determine the radius and I need to determine the height. And the only way I can do that is with similar triangles. So this is at a particular instant where this is the radius R1 and this is 200. And this is the height of 600 and this is whatever, H1. I have to use these proportions. 200 over R1 equals the big 600 over H1. From here, I must get rid of R1 because I have no information about R1. I'm only told the height changes at blah, 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 when the height is. So I know that I can't have any R1 in here because I'll get lost. I don't know what to do with it. But I have this relationship that helps me handle that situation. So I finally got to this. I differentiated and I plugged in what I was given. So I determined at any point in time, I mean, it's a particular instant, but I determined at that instant what is the volume, the rate of the volume, which was this. And then knowing that this volume will always be what I pump in, which is a fixed rate, minus what I pull out, which is 8,000. I differentiate both sides, dv1 over dt, dv2, which is constant, this is what I want, minus that 8,000. And then I have to add it in to this. And that's how I got it. They want us to round up to the nearest integer, so that's 6, so I had to put this up to 3, take it up to 3. Yeah, that was the idea.
Can we do another one of those? One of the ones that I know we worked on before, where there's like the person's walking from the pole.
Yes, I'm ready.
Okay, so streetlight is mounted at the top of a 15-foot pole. A man 6 feet tall is walking away from the pole with a speed of 7 feet per second along a straight path. How fast in feet per second is the tip of his shadow moving when he is 45 feet from the pole?
Okay. So again, the same idea. So this is why. So they're basically asking us dx plus y over dt. When x plus y is, you said 45 feet?
Correct.
Okay. So again, this is a trap. We cannot put 45 feet in there till the very last step. Okay. So similar triangles. I do have dx over dt. This is given to us. What I don't have, I do not have dy over dt. Dx over dt. So dx plus y over dt is basically dx over dt plus dy over dt. This is given to us, 7. But I have to determine this. And then plug in x plus y equals 45. But this is my question. Once I find this, then I find this. So, similar triangles again. This triangle, similar to this triangle. Because they have congruent angles. This angle is the same with this angle, and this one is common. Of course, these have to be the same as well. No other way. So, we start with a common angle. 6/15 equals y over x plus y. Is this clear?
Yes.
So 6/15 y over x plus y. Careful. 6 and y have to come from the same triangle. 15 and x plus y have to come from the same triangle. That's the trick. Therefore, cross multiply. So 6x plus 6y equals 15y. Move 6y to the other side. Differentiate both sides. I'll simplify by 3. 2x equals 3y. This prime, this prime. 2 dx over dt equals 3 dy over dt. I'm after dy over dt. Knowing dx over dt is 7. 2 times 7 is 14 divided by 3. Of course, in feet per second. So now, they want us to determine this sum, dx plus dy. So dx over dt plus dy over dt when x plus y is 45. Okay. If x plus y is 45, then 6/15 equals y over 45. So I'll simplify, or I'll multiply both sides by 15. So then y equals 18 feet. So dx of, oh, actually, I don't need it. So dx over dt is 7, and dy over dt is 14/3. I don't need anything. It's a hoax. So 21 plus 14 divided by 3, 35/3 feet per second.
Thank you.
Any questions on this? Other questions? We know how to graph a piecewise defined function, right?
Yes.
We know how to find limits. We know how to find the definition, the derivative with using the definition of the derivative, right?
Yeah.
If we are given a function, go ahead.
What about some optimization problems?
Okay. Anything? Yes, I'm ready.
4.7.
Optimization 4.7. Yes.
How about this one? What is find the dimensions of a rectangle with in meters with a perimeter of 92 meters, whose area is as large as possible.
Any relationship here?
It doesn't say any.
That's it?
Yeah.
Okay. So the perimeter equals 92, which means 2x plus 2y equals 92. Of course, I'm going to divide by 2, and I get 46. The area equals x times y. I can't have two variables, so I'm going to remove y from here. 46 minus x. Put it here. So x, 46 minus x, negative x squared plus 46x. A prime of x, 2x plus 46. A prime of x, A prime of x equals 0, means x equals 23 meters. Does this give a maximum? I have no clue. I have to show. Looking at this, at 0, it's positive, and afterwards it's negative. So it's guaranteed to be the maximum. What is the maximum? I don't know. It's a of 23 is the maximum. So negative 23 squared plus 46 times 23. Lazy people, lazy people. Use a calculator. Plus 46 times 23. 529 meters squared. I don't know if they're asking, but I will always determine it. The maximum. So if x is 23, 46 minus 23 is also 23. And this is always true. The rectangle with the largest area is a square. Is this okay?
Yeah, that's right.
Perfect. Do we know how to use the definition of the derivative to find the derivative and then check with differentiation rules? Yes or no?
Yeah. I have another question from the 4.7 optimization stuff. I don't actually get this one in WebSign. It was 12 for a piece of wire, 14 meters long. It's cut into 2 pieces.
Yeah, we did this problem together.
Yeah.
So 12 meters or meters, right?
14 meters. One is bent into a square and the other is bent into a circle.
Okay. So the square is x, so that this must be 4x. And the circle, the circumference is pi r squared. I'm sorry, I didn't mean the area. The circumference is 2 pi r. So this will be 2 pi r. And we want to maximize the area, is it? I forgot.
Yeah, it's
Okay.
Maximize area
And minimize.
and minimize. Yeah,
Yeah.
maximize and minimize.
Okay.
In the square.
Okay.
Oh yeah, it doesn't matter, but yeah.
So the area would be x squared plus pi r squared. I cannot have two variables. So I have to get rid of something here. But I know that 4x plus 2 pi r must equal 14. So I'll divide both sides by 2. And then I'll solve for either x or r. I don't know which one is easier. Maybe x. So 7 minus pi r over 2. So this is a of r. I have to replace this here. So now a prime of r. 2, 7 minus pi r over 2 times the inner function prime. 7 over 2 is 0, but I have negative pi over 2 plus 2 pi r. Ugly, very ugly, but it is what it is. So I'll simplify these two. So I have a prime of r as negative pi over 2 times 7 minus pi r plus 2 pi r. Awful. I will set this equal to 0 and see what I come up with. 7 minus pi r over 2. I'm just checking my calculations here. 2 times the inner function prime, 2 pi r. These two are gone, so negative pi over 2. This is correct, this is correct. Okay. Good, let's see. The negative pi over 2, 7 minus pi r plus 2 pi r equals 0. I will divide both sides by pi, and I will multiply by 2. Negative 7 plus pi r plus 4r equals 0. R, pi plus 4 equals 7. R equals 7 over pi plus 4. You have to enter it like this, because I believe, if I remember correctly, they don't want any approximations. Does this give a max or a min? I have no clue. I'm going to have to approximate it. I just want to see what it is. I have to study the sign to make sure that this is okay. When r is 0, when r is 14, negative 1/2, 7 minus 14 plus 28. I factor out. I factor out pi from here. So negative 1/2, 7 minus pi times 14 plus 28. This should be positive. So negative 0.5, 7 minus pi times 14 plus 28. This has to be positive. Let me make sure I entered it correctly. It is 47, 46 point something. Good. According to the sign change. So now, in here, I have X. No, I have R. I have to find X. 7 minus pi R over 2. Parentheses. 7 minus pi times R divided by 2. Okay. So I'm back now to the area. So x squared, 1.96 squared plus pi times 0.98 squared. I get here 6.9. When R is 0, when R is 0, I have to square x. 3.8. When R is 14, no, R cannot be 14. The maximum R can be when R is 0, sorry. When R is 0, then we bend everything into the square. When R is 0. When X is 0, R is 7 over pi. Maximum it can be is 7 over pi. Okay. So in R, when R is 7 over pi, again, when R is 0, X is full. So that's why I squared. When X is 0, R is 7 over pi. So the area would be 49 over pi. 16 roughly. So, absolute min, absolute max. So, finally, when we bend the entire 14 meters into the square with R being 0, so the whole thing, then we get the absolute minimum area. This is nothing. Wrong. Doesn't make sense. From 3.8 cannot drop to 6.9. It can go high from 6.9 to 16. That's okay. So I have an error here. So that's wrong. So this has to be the absolute min. So the absolute min is when R is 7 over pi plus 6. Now I don't know because I don't see the problem. So I don't know if they want us to enter R or they want us to enter X. So if they want us to enter X, then you enter this.
Let me try.
If they want us to enter R, then you have to enter this. But I still have to work on my mistake here. So I'm going to start a new video because I passed 20 minutes.